Hello my dear student, welcome again. I am Soham Jagat with subject science, and in last session we started chapter number 9, that is force and laws of motion. And in last session we have seen inertia, second law, momentum and some example of inertia. So let's start this session with second law of motion. Let's recall second law of motion. Second law of motion states that rate of change of momentum is proportional to applied unbalanced force, and we have derived mathematical formulation of second law as F is equal to ma. Now you know what is F. F is force, m is mass and a is acceleration. Let's put a value of a here. So I got F is equal to m v minus u divide t. A is v minus u divide t, that is rate of change of velocity. Now think about a situation where I want to decrease impact of force. I want to decrease impact of force. What should I do? I can decrease mass, so I can decrease force. Why? Because this mass is proportional to force, so I can decrease mass. But our object are almost has constant mass, so I cannot decrease this mass to decrease force. What can I do? I can increase time to decrease this force. Why I should increase time? You can see here in relation this t is in inverse proportion with f. So with increase in time I can decrease impact of force, or with decrease time I can increase impact of force. Let's see with some example. In our daily life we encounter with second law of motion. Let's take example of cricket. While catch the ball, fielder takes his hand in the direction of ball. Suppose ball is moving like this. So what fielder do? But if he take his hand in direction of ball, it will not hurt to his palm. So what he is doing by taking his hand back? By taking his hand back, he is trying to increase in time to change velocity to 0. What he is trying to do? He try to increase time. So with increase in time, impact of force will decrease. So by increase in time, time of velocity of ball comes to 0. That is change in velocity. That is acceleration. If acceleration is reduced, force is reduced. If acceleration will increase, force will increase. So I hope now you understood why increase in time is important. So our hand will not affect by force of motion and it will not hurt. Let's take another example. In long jump and high jump game, athlete fall onto cushioned bed or sand bed. Why cushioned bed or sand bed? if he land on solid hard surface, his velocity will decrease to 0 in sudden time or very less time. But if he will land on cushioned bed, his timing of landing will be more. And by this formula we can see that if time is increased, force will decrease. Time will increase of decrease in velocity. If this velocity sudden change to 0, the time will be very less. And if time will be very less, this force will be very large. Reverse example, we can think about karate player. Karate player break the bricks and ice plate with one impact. Why? He impact in a very little time. So time is very low. When time is very low, the impact of force will very high. So with less mass and very high velocity that decreases to 0 in very less time, he produce more force, more impact. So the karate player breaks the wood or ice plate or any kind of plate by sudden impact on that particular object. So I hope now you understood how second law of motion impact in our everyday life, and we can observe this law all around us. Now let us see how first law of motion can be stated by second law of motion mathematically. So the second law of motion is F is equal to ma. So F is equal to m v minus u divide t. Let's take this t here. So I got Ft is equal to m v minus u. For force is equal to 0, for F is equal to 0, what I will get? I will get 0 is equal to m into v minus u. So this m comes to denominator and it will be 0. Therefore I got v is equal to u. How? V minus u is equal to 0. So we can state that if force is 0, the object will continue its motion with velocity u till time t. And if this velocity is 0, it will not further move till time t and till any external force apply on it. So in this way we can derive first law mathematically from second law. Now let's take important part of physics, that is numerical. Let's see numerical of example number 9.1. The data given in example number 9.1 is a constant force acts on an object of mass 5 kg for duration of 2 seconds. It increased object velocity from 3 meter per second to 7 meter per second. Find magnitude of applied force, that is first question, and continue. Second question is given that now if the force was applied for the duration of 5 seconds, what will be the final velocity of object? Let's understand data first and then try to derive given quantity from data. In the data, we have one object that has mass of 5 kg and we apply some force, and by applying this force, this object gains some velocity, and to gain this velocity it takes 2 seconds of time. So we have to find force first. So I read this data and derive its given data. A constant force act on object with mass 5 kg. So I will write m is equal to 5 kg. For the time duration of 2 seconds, I will write t is equal to 2 seconds. Don't forget to write unit of every quantity. Velocity increased from 3 meter per second to 7 meter per second. So 3 meter per second is initial velocity, that is u is equal to 3 meter per second, and final velocity is 7 meter per second. And we want to find force. Now remember the formula of force. We have only one formula of force, that is F is equal to ma. Now let's think. We want to find F. We have mass. Yes, we have mass, but we don't have acceleration. But we have velocity change and time. So we can derive acceleration by formula v minus u divide t. Now we have all value m, v, u and t. Let's put the value. Mass is 5 kg. Velocity is 7 minus initial velocity is 3 divide time taken is 2. So I got 5 into 7 minus 3, that is 4 divide 2. This will be cut by 2. So I got force is equal to 5 2s are 10 Newton. Don't forget to write unit of each and every quantity. So I got F is equal to 10 Newton. So let's move on another part of this numerical. Find the magnitude of applied force, that we find as 10 Newton. Now if the force applied for the duration of 5 seconds, now force is applied for the duration of 5 seconds. What will be the velocity? What will be the final velocity that we have to find? So we have formula of acceleration. A is equal to v minus u divide t. And we have formula F is equal to ma. Make subject A here. So I got A is equal to F divide m. And put this value of A here. A is F divide m. So I put F divide m is equal to V minus U divide T. Now we have force is 10 Newton. So now we have F divide m is equal to V minus U divide T. So I have F, that is 10 divide m, that is 5, is equal to V. V in this case we have to find, and U, that is 3 divide T. Now T is not 2. In our second case we have T is equal to 5 seconds. So I write T is equal to 5 seconds. This 5 will be cut and we got 10 is equal to V minus 3. So 10 plus 3 is equal to V. So we will get V is equal to 13 meter per second, which means by applying force of 10 Newton, initial velocity 3 meter per second, will increase to 13 meter per second in duration of 5 seconds. So I hope you understood this example very well. What we do, we take formula first, F is equal to ma, then convert this a into velocity and time, and from that formula we got F, and by using this formula a is equal to v minus u divided t, and convert this a into F and put F by m in place of a, and by putting value of this force, mass and velocity and time. Now let's take example number 9.2. Which would require greater force, accelerating 2 kg of mass at 5 meter per second square or 4 kg of mass at 2 meter per second square. So in this case we have to find force. Force for what? We have two cases here. First is mass of 2 kg. This mass of 2 kg, we want acceleration of 5 meter per second square. And second case is mass of 4 kg, and we want to give acceleration to this 2 meter per second square, and we want to find which object required more force to gain this acceleration. Now we have only one formula that contain force, mass and acceleration. Which is this formula? This is nothing but F is equal to ma, second law of motion. So I put here 1 1 1 because it is for first case. So I put F1 is equal to m1 a1. Now put the value of relative quantity. I have mass of 2 kg in first case, and I want to give acceleration of 5 meter per second square. So I got F1 is equal to 10 Newton. Similarly, put formula here. F2 is equal to m2 a2. So I have mass 4 kg here, and I want to accelerate this at 2 meter per second square. So I got 8 Newton as F2. So we can see clearly here that our F1 is greater than F2, which means this first object requires more force to put into required acceleration compared to second. So the answer is first object requires more force than second object. Now let's take example number 9.3. This example number 9.3 is very interesting and very conceptual detail. I read the data first. A motor car is moving with the velocity 108 km per hour, and it takes 4 seconds to stop after applying brakes. Calculate the force exerted by brakes on motor car if motor car has mass of 1000 kg. So first, understood data. We have one car with total mass of 1000 kg, and it is going with the speed of 108 km per hour, and it applies brakes. By applying brake, after 4 seconds car will stop, which means its velocity now is 0. So let's derive data first. So this is our car which is going with initial velocity u is 108 kilometer per hour. We'll put data in meter per second, that is SI unit. So convert this kilometer per hour into meter per second. So to convert this kilometer into meter, I have to multiply it with 1000. And to convert this hour into second, I have to multiply in denominator with 3600. So I got here, this will be cut. So I got 30 meter per second as u. Now car applies brake and it will stop. So by stopping position, we have velocity as 0 meter per second. So our initial velocity u is 30 meter per second, and after applying brake, velocity is 0 meter per second. And time taken by car is 4 seconds. And we have total mass of car with passenger as 1000 kg. So we have to find force exerted by brakes. So F is equal to Mn. We have one formula, that is F is equal to Mn. We want to find force exerted by brake. We have mass but we don't have acceleration. So put value of A as V minus U divide T. Now we have all values of M, V, U and T. So put value of M as 1000 kg. V is 0 meter per second. U is 30 meter per second. And time taken is 4 seconds. So we have 4, 25, 0. So we have 250 into minus 30. So here we have 0, 0 and 75 Newton. So we have force as 7500 Newton. But here you can see one minus sign, that will come as minus 7500 Newton. Now you will think how this minus sign came here. So we know that this force is vector quantity, and for vector quantity we need both magnitude and direction. This negative sign suggests that force applied by brakes is in opposite direction to movement of car, which means car is moving in this direction and the force applying by brakes is in opposite direction. So this minus sign indicating that this force trying to reduce speed of any object, or in this case car. Remember, when final velocity v will decrease, always we will have force as negative, and when final velocity increases, it will increase in velocity, means force will help to increase velocity. In that case we will get force as positive, but when final velocity decreases we will get force negative. Now let's take example number 9.4. Let's first derive given data. We have force that is fixed as 5 Newton, and we have two objects. One object with mass m1 and acceleration is 10 meter per second square, and we have another object which has mass m2, 20 meter per second square, and we want to find if we tied both this mass together, what will be acceleration in this case. So I hope you understood data. We have fixed force and two objects. This force can accelerate m1 mass to 10 meter per second square, and this force can accelerate m2 mass to 20 meter per second square. So if I want to find acceleration, what I want? I want F is equal to ma. From this formula, if I want to find A, I need both mass and force. So if I look at this example, I have force, but I don't have mass. So first of all, I have to find mass of both this m1 and m2, so I can put m1 plus m2 here. So to find this m1, I have to apply same formula, that is F is equal to ma. Put value of F, that is 5, is equal to m1. Here we have m1 into a1 as 10. So I got m1 is equal to 5 divided 10, that is m1 is equal to 0.5 kg. Similarly, we can apply formula F is equal to ma here. F is constant, A and M is m2 a2, force is 5 Newton, m2 we have to find, a2 here we have 20 meter per second square. So m2 is equal to 5 divided 20. So m2 I got 0.25 kg. So now I have both m1 and m2. Now I can put this value of m1 plus m2 in this equation. I have F is equal to m1 plus m2 into A. Now put the value of m1 and m2 here. So I will have 5 plus m1 is 0.5 plus m2 is 0.25, and acceleration we want to find. So I have 5 is equal to 0.75 into A. So I have 5 divided by 0.7 A. So by simple calculation, I will get answer as A is equal to 6.67 meter per second square, which means if I tie both this mass and apply same force on it, I will get acceleration of 6.67 meter per second square. So I hope you understood all this example. In this lecture, we have seen some daily life example of second law of motion. How can we mathematically derive first law by second law, and few important example of second law.